Hi, I'm Richard C. I'm a math tutor at Wyzant, and we're going to do this nice little example from calculus. Uh, what we're going to do is start by sketching the function that we're interested in, which is, I'm just going to put a y here because that's the way we would usually see it in school, 4x minus x squared. And now I'm going to write it a little differently, negative x squared plus 4x. So you should know by now, if you're taking calculus, you should be familiar with the parabola, and you should realize that this is a parabola opening down. And we're going to find the x-intercepts by setting y to 0. And now I'm just going to take out an x. Maybe I'll take out a negative x. So that's going to give me x minus 4 here. So I get two answers. X is equal to 0. That's coming from the first term here, x equals 0. And then from this term here, x equals 4. So now I'm going to just go ahead and sketch this graph. I know it goes through 0, 0, and 4, 0. And I know it's a parabola and it's opening down because this leading coefficient is negative. And so I can sketch my graph. It will look something like this. And we can fill in a lot more information here, but we don't really need to. If you remember how parabolas work, you can find the vertex and the maximum height and so on. We don't need any of that. Now, the problem is asking for the area under the curve, basically the area between the curve and the x-axis. So I'm just going to fill that in with a color. So this is the oops, sorry about that. This is the area. Try to be a little more careful with my coloring, but this is the area that we want. So the area is just going to be the integral from 0 to 4 of 4x minus x squared dx. And that's a nice, easy integral to find. So this is going to, when we take the integral of 4x, we're going to get 2x squared. And when you take the integral of negative x squared, you're going to get negative 1/3 x cubed. And we want to evaluate that from 0 to 4. So this should all be very familiar to you. If you differentiate 2x squared, you're going to get 4x. The 2 is going to multiply by the 2. You're going to get 4, and the power goes down. These are both power rule forms of antiderivatives. And so 3, when you differentiate this, you're going to get 3 times a third, which becomes 1, and then x squared. And so this is very, very easy. Now we're just going to plug in. So it's 2 times 4 squared minus 1/3 times 4 cubed. So that's the 4 part. But then you can see the rest of this is just going to be 0. This is going to be 0 minus 0 here, coming out of the 0 part. So you're plugging in 4 first, and then you're subtracting what happens when you plug in 0, but you see that's all zeros there. So we're left with 4 squared is 16, so it's 2 times 16. minus 1/3 times 4 cubed. 4 cubed is 64. So 2 times 16 is 32. And on the calculator here, when you take 64 and divide by 3, you're going to get 21 1/3. And then when you do the subtraction, you're going to get 10 2/3. And that's our answer. That's the area represented by this green region here. They're not giving us units, so this would be area is always going to be units squared. We don't know what the units are, but it doesn't really matter in this problem. And that's it. We've solved it. So a very nice, easy one. And hopefully this will help you with your calculus work. And I wish you good luck in your explorations of calculus this year. Bye-bye.